The impact of warming on Greenland's firn outweighs that of cooling. Greetings everyone! Today's video focuses on a recent publication in the cryosphere that delves into the effects of warming and cooling on Greenland's firn, which is the layer between snow and glacial ice. Thompson-Munson led this study, which emphasizes how warming diminishes the firn's capacity to retain meltwater at a faster rate than cooling can replenish it. This discovery holds significant implications for the conservation of Arctic glaciers and indicates that reversing global warming might be more difficult than initially thought. Without any delay, let's begin our discussion. Led by Thompson-Munson, a PhD student at CIRES and ATOC, a team of researchers conducted a study utilizing a physics-based numerical model to evaluate the effects of both warming and cooling on firn, the porous layer located between snow and glacial ice across the entirety of the Greenland ice sheet. Assisting Thompson-Munson in this endeavor were her advisors, Jen Kay, a CIRES Fellow, and Brad Markle, an INSTAR Fellow. The discrepancy in the extent of transformation experienced by the firn layer as a result of fluctuations in temperature is not symmetrical, noted Thompson-Munson. When we examine the span of thousands or even millions of years, we observe an overall asymmetry in the behavior of ice sheets. They have the propensity to rapidly melt, but their growth is a slow and gradual process. The identification of this asymmetry in the firn layer is just one small component of the larger puzzle. Covering the majority, approximately 90% of the Greenland ice sheet, are layers of firn. Found at higher altitudes, this porous and spongy material, along with snow, blankets hundreds of meters of ice. Its crucial role lies in acting as a protective barrier against the rising sea levels, thereby playing a vital part in the preservation of Arctic glaciers amidst the warming climate. The permeable nature of firn enables water to permeate through it, eventually reaching the solid ice layer beneath. Instead of flowing into the ocean, this water has the potential to refreeze, contributing to the growth of the existing ice sheet. The findings of this study indicate that the efficiency of firn in storing meltwater is being significantly impacted by rising temperatures, and contrary to expectations, even cooling temperatures may not facilitate a full recovery of the firn. According to Thompson-Munson, the warming has a detrimental effect on the firn air content, or the sponginess. The loss of sponginess is greater due to warming than what can be recovered through cooling. This is significant because the porous firn plays a crucial role in mitigating the ice sheet's contribution to rising sea levels. In order to comprehend the reaction of firn to fluctuations in temperature, the research team utilized a physics-based computer model known as snowpack, with a specific focus on the variable of temperature. This study stands out in two significant ways. Firstly, it examines the effects of both increasing and decreasing temperatures on Greenland firn, a unique approach not previously undertaken. Secondly, unlike previous studies that concentrated on limited geographical regions, this research encompasses the entirety of the ice sheet. According to Kay, the loss of mass from the Greenland ice sheet occurs at a faster rate during periods of warming compared to the rate at which it gains mass during cooling. The significant progress made by this study lies in its revelation that Greenland's firn plays a crucial role in this asymmetrical response, favoring warming over cooling. The study raises a significant inquiry about geoengineering and its potential to reverse global warming. It suggests that any strategies aimed at reducing temperatures in the Arctic may not be as effective in preserving ice and snow as initially thought. In order for firn and glaciers to recover, the cooling effect would need to surpass the warming effect. Reverting to the original conditions would require further cooling or the alteration of additional variables, explained Thompson-Munson, undoing what has already been accomplished. To support our channel's growth and ensure broader awareness, kindly hit the like, share and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.